Hey everyone! So we are in section 5.2 for AP Statistics. So we're today going to be getting into the probability rules and doing a couple of examples. So let's dive right in. In this section, we're going to be able to describe chance behavior with something called a probability model. We're going to be able to define and apply some basic rules of probability. These are rules you probably know from previous courses, but it's good to review them. We're going to look at some probabilities from two-way tables, and then also constructing Venn diagrams and determining probabilities from them. So some vocabulary about probability models. Sample space, which we sometimes abbreviate with the capital letter S, is the set of all possible outcomes in a chance process. And then a probability model is going to be a description of a chance process, and it consists of two parts. It also consists of that sample space that we just talked about, and it also has the probability of each outcome. So for example, if you were to toss a coin, the sample space would be either heads or tails, and then the probability, you have a 0.5 chance of heads and 0.5 chance of tails. That would be your probability model. Probability models can take on many forms. It can be a Venn diagram, like shown here. You can have a tree diagram, which we'll get more into in the next sections. You could simply have a list or a chart, anything that shows you your sample space. Probability models allow for us to find the probability of any collection of outcomes. Now, an event is going to be any collection of outcomes from some chance process. So that is, an event is going to be a subset of the sample space. So it's a piece of it, it's a part of it. Events are usually designated by capital letters, so like A, B, C, and so on. So for example, specific events might include flipping 3 heads in a row. Or when you roll 2 die and then you get a sum of 5. That could be the event. So you can see from the Venn diagram, this blue box represents all possible events. That will be our sample space. And then inside is going to be all the ways that you can get that particular event A. Now, a complement is going to be an event that did not occur, so not A. So for instance, if event A is the airplane takes off on time, the complement of A, we say a complement, so it's denoted by this little C in the exponent. You might also see a like an apostrophe there instead of the C. The complement of this would be the airplane does not take off on time. So if there's, for instance, a 20% chance it takes off on time, there would be an 80% chance it does not take off on time. All right, let's look at an example very quickly of this scenario of rolling 2 dice. So as you can see, there are a lot of possible outcomes in our sample space. Specifically, there are 36 possible outcomes when you roll 2 die. In statistics, there is a difference between rolling a 2 and a 1 versus rolling a 1 and a 2. Those count as separate things. However, rolling a 1 and a 1 is just one outcome because I can't tell the difference between one or the other. So the sample space, you could either draw pictures like this, or you can simply write out 1 1, 2 1, 3 1, 4 1, and then 1 2, 2 2, 3 2, 4 2. Write out all 36. Yes, you actually have to write out all 36 on your notes, all 36 outcomes in our sample space. And then the probability model is the combination of the sample space, so all 36 outcomes, with the probability of each. So since the dice are fair, each outcome is equally likely. So each outcome has a probability of 1 out of 36. Now, for this example of rolling 2 die, let's say we have an event, and let's have that event be rolling a sum of 5 with 2 dice, okay? So the probability of A would be that we have a sum of 5. Why A? Why not? Kind of like when you have algebra, why X, just what it is. The event space, how many ways can you actually get a sum of 5, there are 4 different combinations. You could get a 1 and a 4, a 2 and a 3, a 3 and a 2, a 4 and a 1. So if we wanted to know the actual probability of this event, the probability of event A would be 4 out of 36, or that simplifies to 1/9. What would be the complement of this event? Simply not rolling a sum of 5. You don't need to be any more crazy from there. You don't want to have to be like, oh, give me a sum of 2 and 3 and... No. Just say it's not a sum of 5, and you're good to go. Okay. Basic rules. You should know these at this point in your, lives, but it's always good to review them. So, the probability of any event is a number between 0 and 1. Okay, we operate in fractions or decimals, not percentage. All possible outcomes together must have probabilities whose sum is 1. So think when you roll, or when you toss a coin, you have a 0.5 chance of heads, 0.5 chance of tails, 0.5 plus 0.5 is 1. Now, this is important. If all outcomes in the sample space are equally likely, the probability that an event A occurs can be found using this formula. In the numerator is the number of outcomes corresponding to that event, and in the denominator is the total number of outcomes in the sample space. So we saw that in our last example, There were 4 ways to get the sum of 5 out of all 36 options, so that's why we got a probability of 4 out of 36. Now, the probability that an event does not occur is 1 minus the probability that the event does occur. We saw that in our complement. So if I had a 4 out of 36 chance of getting a sum of 5, I would have a, quick math, 32 out of 36 chance of not rolling a sum of 5. And then lastly, if 2 events have no outcomes in common, the probability that one or the other occurs is just going to be the sum of their individual probabilities. Okay? Now, new term, mutually exclusive. 2 events that cannot occur at the same time are mutually exclusive. There are no common outcomes. If events are mutually exclusive, to find the probability that one or the other occurs, you would simply add their probabilities together. Visually, if I look at this Venn diagram here, there's no overlap between my 2 events, right? These are called disjoint events. They are mutually exclusive. So some examples. A student is either a junior or they're a senior. You cannot be both at the same time. You can either land on heads or you can land on tails. You can't do both at the same time. You either roll a sum of 5 or you roll a sum of 6 with 2 die. You can't do both at the same time. Those are all mutually exclusive events. Okay? All right, let's go through this example. You don't have this one on your notes, so just follow along on the video. Online learning courses are rapidly gaining popularity among college students. Randomly select an undergraduate student who is taking online learning courses for credit and record the student's age. Here is the probability model. Okay? So we see we have the different age groups and then the probability that they were in each age group. So we want to know, is this a legitimate probability model? So remember, to be a probability model, you need to have all possible outcomes listed, and it should sum to 1, and all your probabilities should be between 0 and 1. And then we also want to find the probability that the chosen student is not in the traditional college age group, so outside of this 18 to 23 year range. So this is a legitimate probability model. Each probability is between 0 and 1, and if I add up the probabilities, it adds to 1. Now this is a really handy fact. If I had only found the data for the first 3, I could know, as they told me it was a probability model, I could simply subtract these 3 from 1 to find out what's missing. Now, find the probability that they're not in the traditional age group. This is that idea of a complement, y'all. we just have to subtract 1 minus the probability that it is in that age group, and I get 0.43. Now, I could have just simply added 0.17 to 0.14 to 0.12, but this one's a little bit quicker as far as the calculations are concerned. All right, I want you to pause this video and you try example 2. Okay, so press pause and try this. Here is the answer for A, and then for B, and then for C. So hopefully you tried that and that wasn't too tough for you. If it was, go back and look at the first example again, see if that can help you. All right, next example. What is the relationship between educational achievement and home ownership? A random sample of 500 people who want to participate, in the 2000 census was chosen. Each member of the sample was identified as a high school grad or not, and as a homeowner or not. Overall, 340 were homeowners, 310 were high school graduates, 221 were both. So, sometimes a two-way table is going to be already presented to us. In this case, they just gave us numbers and we have to organize it. So in your notes, I want you to take the numbers and organize the table. So clearly, if they took a sample of 500, that should be your grand total, and then work backwards from there. So go ahead, press pause, fill out that table. After you have your table filled in, we want to find some probabilities. What's the chance or the probability that we select a random high school graduate? Or what's the probability we select a high school graduate who owns a home? Or the probability we select a high school graduate, or that we select someone who owns a home. Okay? So those answers are here. So 310 out of 500 are high school graduates. 221 are graduates who own a home out of the 500. And then the graduates, or they own a home, is going to be this right here. Okay. All right, let's look at one more. So, and or, what does it mean when you are asked? Soup or salad? Cream or sugar? Do you want cream and sugar or just cream or sugar? Do you want soup and or soup or salad? When we have the word and, we're talking about the intersection of two Venn diagrams right here. Okay, so if these events were mutually exclusive, their intersection wouldn't exist. Okay, or is everything all together, this or this, so it can be either here, here, or here. Okay, notation, we use this upside down U for intersection. For union or we use just the U. Okay. Now, very important, and this formula is on your formula sheet, so it's not something you have to memorize, but this is called the general addition rule for two events. So if we have two events, A and B, then the probability of getting A or B, you would simply add the two probabilities of A and B together and subtract the probability of A and B occurring. So let's go through an example or two together. A single card is chosen at random from a standard deck of 52 cards. What is the probability of choosing a king or a club? So I'm going to use this rule. So we do need to ask ourselves, if it's an or question, are the events mutually exclusive or disjoint? In this case, they are not. So I would need to add the probability of king to the probability of club and subtract the probability of king and club. So hopefully you have some good knowledge of playing cards and you can see where I got this answer. Wrapping up quickly, here's the New Year's Eve one. Read this to yourself. These are not mutually exclusive, so I would have to add the probability of being driving while intoxicated to getting an accident and subtract the probability of both and get this answer here. I want you to try this one here. Here are your answers. Hope it goes well.